Good day, ladies and gentlemen. I welcome you all to this session on compilers. We'll try and understand compilers in two parts. Firstly, we'll understand what a compiler does, and then we'll proceed to understand how a compiler does its job. It's a wonderful quotation from Dijkstra. It says, "The computing scientist's main challenge is not to get confused by the complexities of his own making." Now we'll try and understand what a compiler does. Here, this is a compiler. This is a high-level program such as C, COBOL, ALGOL, PL1, Fortran. This is an example of a program. What the compiler does is it translates this program into machine level instructions which a machine can understand and operate upon. So that's what a compiler does. It translates into ones and zeros machine level instructions. Now why is it that it's only in terms of ones and zeros that a compiler translates into? That's because the CPU of a computer can understand and operate only based on ones and zeros. That's on-off values. That's how the electronic circuitry is built inside the CPU. That's a binary system in ones and zeros. Now what we have done is we have seen what a compiler does. It translates high-level program into ones and zeros, machine-level instructions, and now we'll proceed to how a compiler does its job. We'll see that now. A compiler has got three main phases: lexical analysis, parsing, and code generation. It's not true that these are the only phases. There are more, such as code optimization, but we are limiting ourselves to these three for easy understanding. Now, this is an English language sentence, "John ran quickly." If we were to write it like this, John, like this, then this resulted because of probably a typing error. We know that it's an error because according to the English language grammatical rules, it is not correct to start a word with @sign. So that's how it's easy to correlate with an analogy in English language. We'll try and do that with compilers as well for easy understanding. The lexical analyzer, we are going into lexical analyzer. This is the input John quickly, John ran quickly, like that. What the lexical analyzer does is it separates them into tokens, John quickly. So these are the tokens. So it separates them on the basis of what are called lexical rules. And when the input does not obey the lexical rules, then a lexical error is reported by the lexical analyzer. However, the lexical analysis continues. So this is incorrect and this is correct because whether it follows the lexical rules or not, depending on that, these are determined. So when we go to our programming example, A is equal to B plus C, what the lexical analyzer does is it separates them into tokens. So these are all the various tokens that get generated because of lexical analyzer. The input is translated into these all tokens. And so lexical analyzer also creates what's called uniform symbol table. So it will contain these all tokens and their corresponding token types. That's identifier or literal or terminating symbol, so on and so forth. And it also discards comments. That's because comments are not required for program execution. So lexical analyzer translated into tokens and their corresponding token types. Now what we have done here is, in summary, we have understood what a compiler is, and then we proceeded to understand how a compiler works. We've seen the first part, lexical analysis. The remaining two parts, parsing and code generation, we'll see in the next video, 016. Thanks, ladies and gentlemen. Bye.